All right, so we're going to talk about the unit circle, guys. Big when we talk about, going through the future for content stuff that we're going to be discussing, doing a lot of stuff with the unit circle. So really got to pay attention here, right? So this might be a longer video today. So what is the unit circle? The unit circle is a circle centered at the origin with a radius of 1 unit. So the basic things that you need to know is that you have a radius of 1. Okay? So now what I'm going to do is I'm going to draw a radius from the origin. Okay? So my origin is right here in the middle. So there's my origin, right? And I'm just going to draw a radius of 1. Okay? And we're just going to label it a radius of 1. So that's a radius of 1 right there. Okay? So it says, draw a line from that point that's perpendicular to the x-axis. What is the result? So from that point, we're going to draw a perpendicular line. What happens there is that we get a right triangle. So that is my result there, a right triangle. Okay? Now, just like anything in the coordinate plane, every point is in the form of x, comma, y. So we say, okay, what are the coordinates of the point? Every point on the circle, the same as anything in the coordinate plane. It's just x, comma, y. All right? We're going to label that reference angle theta. Okay, so there's my reference angle. Remember we talked about reference angles, right? How do you get your reference angle? You go from the terminal side to the x-axis, which in this case, my terminal side is my radius of 1 or my hypotenuse. Okay? So that means then, basically, my horizontal distance here is going to be x. My vertical distance is going to be y. Okay? Same thing, right? Okay? So it says, define the following in terms. Well, what is sine equal to? Sine is equal to opposite over hypotenuse. So look at that. Based on where theta is at, what is your opposite side? Well, your opposite side is y. Your hypotenuse is 1. And so basically on a unit circle, then we just say, okay, sine is equal to the y value of the ordered pair. Now let's look at cosine. What is cosine equal to? Adjacent over hypotenuse. So what is your adjacent side? Your adjacent side is x. Your hypotenuse is 1. So cosine is equal to x over 1 or equal to x. Okay, what would tangent of theta be equal to? Okay, what would tangent theta? So tangent theta is equal to opposite over adjacent. And so my opposite side is y. My adjacent side is x. So tangent of some sort of value on the unit circle is going to be equal to the y value over the x value of the coordinate. Okay, of the coordinate. Now cosecant, all we're doing then is we are flipping flip sine, right? So that's now going to be the hypotenuse over opposite. So my hypotenuse is equal to 1, and we already defined my opposite side to be y. So to find cosine of theta, all you're going to do is you're just going to, ideally the best bet is to find sine and then just flip it. But if not, if you weren't given sine, then you would do 1 over the y value. Okay? Secant, easiest thing to do would be is to flip cosine. So again, cosine is equal to adjacent over hypotenuse. So now we're going to have hypotenuse over adjacent. My hypotenuse is equal to 1. My adjacent side is equal to x. Okay? And then cotangent. Cotangent, all we're going to do is we're going to flip tan. We're going to flip tan. And so if tangent is opposite over adjacent, that means cotangent is adjacent over opposite. And so what's going to happen there then is we know my adjacent side is equal to x. My opposite side is equal to y. Because how did we get an ordered pair? You go over x up y when you're plotting points. Okay, when you're plotting points on the coordinate plane. So now given that that x comma y is pretty much the same thing as cosine and sine, right? Because how do you find sine of theta? You take the y value. How do you find cosine of theta? You just take the x value of the ordered pair. So what we're going to talk about now is we're going to talk about our quadrantals, okay? And we have 4 quadrantals, okay? One is right here. So quadrantals are points that our axes lie on. So we have our positive x-axis, which right here is either going to be 0 degrees or 360, okay? Which in radians as well, 360 in radians as well is equal to 2 pi, okay? At that point, because we have a radius of 1, our ordered pair there is going to be 1, 0, okay? Our positive y-axis quadrantal, okay, which is 90 degrees, which in radians equals pi over 2. We label that as 0, 1, because what did we do? We didn't go anywhere x-wise. We didn't move up to right. We just went up a radius of 1. So therefore, our point at 90 degrees is 0, 1. Our quadrantal for our negative x-axis here is 180 degrees. That's our half semicircle. Okay, that pi is equal to that. So that's our radians for 180 degrees. And at that point, all we did is we moved left 1, a radius of 1. And so we label that as negative 1, 0. And then last but not least, our quadrantal for our negative y-axis. So that is equal to 270 degrees, which in radians is equal to 3 pi over 2. And now how do we get to this point? We didn't move left or right at all in x. We just went down 1. And so we are going to label that point as 0, -1. So now that I know my ordered pairs, it's real easy to go ahead and just find based on my rules. Guys, I cannot tell you how important these rules are. I cannot tell you how important these rules are. It's going to make our life a lot easier if you remember these rules. Okay, so it wants me to find sine of 90 degrees. So I go and I say, okay, 90 degrees. What is the ordered pair? It's 0, 1. Well, what's my rule for sine? Sine is literally equal to the y value, right? Sine is literally equal to the y value. Sorry, let me shut off my email so that doesn't get in the way of the video, okay? So sine is literally equal to the y value. So we just say, okay, sine is equal to y value, and at 90 degrees, what is the ordered pair there? What is y equal to? Well, it's just equal to 1. So we can say, okay, sine of 90 degrees is equal to 1. Okay? Now, pi over 2, what is that equal to in degrees? That's equal to 90 degrees. So again, I'm only concerned with 0, 1 here. And now what is tangent equal to? Tangent is equal to y over x. So what is my y value? My y value, so tangent, we're going to write it as y over x because that's our rule. And now what's the y value of the ordered pair? It's 1 over x, which is equal to 0 in that ordered pair. Equal to 0. And so the thing that we need to understand, though, is that when we have 0 in the denominator, that makes this answer undefined. It makes that answer undefined. Okay? Whenever we have a 0 in the denominator, our answer is always undefined. Okay? And when we actually get to graphing, tangent, you'll understand why tangent is undefined at pi over 2. We'll talk about that more next unit. Okay? All right, cosine of pi. Well, what is pi equal to? That's equal to 180 degrees, right? So go to the 180 degrees point, your quadrantal there, and say, okay, we've got -1, 0. Well, what is cosine equal to? Cosine is equal to x. And so what is x equal to in that point? -1. So we could say that cosine of pi is equal to a -1. Okay? All right, tangent of 270. So tangent 270, what is our ordered pair there? 0, -1. 0, -1. So again, what's your rule? Tangent's equal to y over x. What is the y value? -1. What is the x value? 0. Right? So we have, again, 0 in the denominator. Okay? What that means then is that this is undefined. Okay, because we got a 0 in the denominator, that makes that whole expression undefined. Okay? All right, tangent of 180 degrees. Again, my rule for tangent is tangent's equal to y over x. So I go to 180 degrees. Okay, I go to 180 degrees. And I say, okay, what is y equal to 180 degrees? Well, it's equal to 0. What is x equal to? -1. Okay? And so what you're getting here is you're seeing 0 in numerator. So when the 0 is in the numerator, our whole answer is just equal to 0. That's the big thing you need to understand. If I get a 0 in the denominator, undefined. 0 in the numerator, 0. Okay, so we have to recall that. All right, for the first time here now we're talking about our reciprocal identities. We're looking at secant. Okay, so what is secant equal to? What is the rule? Secant is equal to 1 over x. Okay. If I don't have cosine ahead of time, I can't just say, okay, well, I'm just going to go ahead and flip to find secant, right? I had found cosine of pi above here. That's not cosine of 2 pi. So if I don't have cosine ahead of time, then I do have to follow the rule. So then what is secant at 2 pi? Well, 2 pi is the same thing as 360, so we're looking at that ordered pair. We're looking at x comma y. Well, secant is equal to 1 over x. So in this case, then, we have 1 over what is x equal to at 2 pi. Or at 360, it's equal to 1. So we just say 1 over 1, which then equals 1. So pretty much if you have the rules, okay, and you have your points labeled, you can find any value on the unit circle. Okay, any value on the unit circle. Okay, and that's kind of what we're going to be doing. I'm going to be asking you to find sine of, 180 degrees. I'm going to be asking you to find cosine of 300 degrees. That's what we're moving towards. Okay? All right, now, to help us kind of define not the quadrantal parts, but the other parts of the unit circle, which are the points in between the quadrantals, so in between 0 and 90. 90, 180, 180, 270, 270, 360. We're going to explore that right now, okay? And so how this unit circle was created, so back in geometry, you guys learned about two special right triangles. You learned about a 45, 45, 90 triangle, and you learned about a 30, 60, 90 triangle, okay? And so we're going to talk about this. So recall, this is past up. This is not new. We have 45, 45, okay? And what you need to understand is that because both of the angles are the same, their sides are going to be the same. So in a special right triangle, our two legs are equal to 1 because our angles opposite of them are the same as well. Okay? So then to find the hypotenuse for this 45, 45, 90 triangle, I'm going to do Pythagorean theorem. Okay? Pythagorean theorem. And plug in for A and B our legs, which are equal to 1. So what that's going to give me then is that's going to give me 1 squared plus 1 squared, which we know 1 squared is equal to 1, so 1 plus 1 is 2 equals c squared. Okay? When I square root both sides, that means that my hypotenuse is then going to be equal to a square root of 2. Now, the dilemma is this though, right? Our unit circle must have a radius of 1. Okay? Our unit circle must have a radius of 1. So what I must do then is I must manipulate our special right triangle, okay? I must now make the hypotenuse is equal to 1. So I have to take my 45, 45, 90 triangle, my hypotenuse right here, because I need to fit in the unit circle, okay? That's why I'm doing that. Again, I need to fit in the unit circle. So how I'm going to do that is I'm just going to divide each side by square root of 2. So what I do to one side, I must do to every side. Okay? And so now what is that going to do? How is that going to change? How is that going to change my triangle? Okay, well, if we take our hypotenuse, which was originally square root of 2, and we divide it by square root of 2, what do I get now? I get a hypotenuse of 1, right? Which is what I wanted. But now I must do, what I do to one part, I must do to every part. So now, which was this side right here, which was originally 1, I'm now also dividing by square root of 2. Okay? We have a problem. That's now a radical in the denominator. So what you have to normally do is you have to normally rationalize it. So what I would just say do is in your calculator right now, just put 1 over root 2, and it ends up giving you a root 2 over 2. Same thing applies here to this other side. These two legs are congruent of this. So when we divide it by root 2, now we have root 2 over 2. And so now I'm going to then go ahead here and estimate from the origin. I'm going to draw a radius of 1. I'm going to fit my new 45, 45, 90 triangle in my unit circle. So again here, remember, it has to have a radius of 1, right? Which we did by dividing it by root 2. Okay, but now look how x and y changes. X now becomes root 2 over 2, and y also becomes root 2 over 2. So that's our taking our special right triangle, building our unit circle, but building it so that it meets the parameters of what our unit circle has to be, which you have to have a radius of 1 or a hypotenuse of 1. Okay? So that means that if we were writing this ordered pair, this is equal to x, this is equal to y, and so you would write your ordered pair for 45 degrees as root 2 over 2, root 2 over 2. Which makes sense. Again, look at what quadrant are we in as well. Look at, we are in our first quadrant here, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it makes sense that our ordered pair would be positive because in quadrant 1, x and y are positive. So 45 degrees in radians is pi over 4. Okay, I'm skipping how to find that again. Well, if you weren't sure, you would do 45 degrees times pi over 180. Okay, and now we just figured out our coordinates. Our coordinates are now root 2 over 2, root 2 over 2. Again, how did I get that? When I divided all sides by root 2, now my x value, instead of it being equal to 1, is now equal to root 2 over 2. Instead of my y value being equal to 1, it's now equal to root 2 over 2. And so now x and y are root 2 over 2, root 2 over 2 in our new 45, 45, 90 triangle that meets the parameters of our unit circle. I cannot stress that. Now, we are going to do the same thing we did above with the quadrantals, except now we're talking about 45 degree. Now we're talking about 45 degree, which my x and y value. Okay, x and y. Okay, we're going to use our same rules. What was sine equal to? Sine was equal to our y value. What is our y value in this case? Okay, sine is equal to our y value. What is our y value in this case? It's just root 2 over 2. So sine of 45 degrees, if you were to type that into your calculator, would tell you that it would be equal to root 2 over 2. Okay, what's cosine of 45 degrees? Well, cosine is equal to x. Remember our rules above. I'm using our rules that we defined above. Okay, what is x equal to in this ordered pair? Root 2 over 2. Okay, now it's asking for cosecant of 45 degrees. Well, cosecant, what do? I go ahead and I flip it. I flip it, right? So when I flip it and I plug it into my calculator, that is now going to give me root 2. Or the same thing as 1 over y. So 1 over y is the same thing as root 2. Okay? Secant of 45. Same thing. I have cosine. I'm just going to flip it. And when I flip it, 2 over root 2 equals just root 2. Which again, this is the same thing as 1 over x, right? Okay, same thing as 1 over x. But it's real easy that once you have sine and cosine, to find cosecant and secant, just go ahead and flip it. Now, what is tangent? Okay, what is tangent of 45 degrees? Okay, well, real quick, I want you guys to come down here and check this out. Okay, little asterisk here. Recall, our rule for tangent is equal to opposite over adjacent. So based on our reference angle here, which we have a reference angle of 45 degrees, our opposite side, okay, so tangent of 45 degrees is equal to, okay, our opposite side, which in this case, based on my reference angle here, okay, our opposite side is root 2 over 2, divided by, I gotta scroll up a little bit here, divided by what's our adjacent side? Our adjacent side right here, based on our reference angle right there. And so our adjacent side is going to be root 2 over 2. And now look what you have. You've got the same value divided by the same value. It's like saying, what is 1 over 1? Or what's 2 over 2? It's just equal to 1. So tangent of 45 degrees is actually very basic. It's very easy to write out. It's just going to be 1. Well, what is cotangent? Cotangent, all we do is we flip tangent. In this case here, cotangent then would also be equal to 1, because when you flip 1, it's just 1. Okay? So I know that's a lot. So the great thing about having a video like this is that you can pause this and you can go back and re-listen to what I'm saying if you're not sure. Okay? Again, guys, this is a lot. This is going to be a long video. Okay? We're going to have to really put some time into understanding this, and that's okay. All right? This is a challenge ahead of us that we are going to be able to overcome. Okay? And so that is just the first half. So now we're going to look at the 30, 60, 90 triangles on the back. So I would pause and just wait for a second to get, if you need to get caught up before we move on to the back here. Okay? So now we're going to look at another special right triangle. We're going to look at our 30, 60, 90 triangle. Okay, we're going to look at our 30, 60, 90 triangle. So let's go ahead and let's draw that special right triangle. Now, it doesn't matter what I put down as the reference angle for this time. I guess because we're saying 30, 60, 90, I'll make the reference angle down there 30 degrees, which means the 60 degrees here. And now if you recall, in a special right triangle, opposite 30 degrees was 1, opposite 60 degrees was root 3, and then by doing Pythagorean theorem, we're going to find our hypotenuse. So we're going to have a squared plus b squared equals c squared. Okay? And so then we're going to go 1 squared plus root 3 squared equals c squared. And so when I do that, okay, that's going to give me 1 plus, whenever you have a radical expression, in this case square root 3, raised to a power of 2, it just gets rid of the square root sign there. And so you pretty much what you have is you have 1 plus 3, which gives you 4. So we have 4 equals c squared, which then that tells me that c then is equal to 2. So my hypotenuse is equal to 2 on my 30, 60, 90 triangle. Now, just like with the 45, 45, 90, okay, just like with the 45, 45, 90, okay, we are going to need to make this a radius of 1. Okay, we're going to need to make that a radius of 1. So now, and actually I'm going to, write that over a little bit closer. I'm sorry, I apologize, guys. So now, make the hypotenuse, we're going to now make the hypotenuse equal to 1. Well, to do that, just like we did with the 45, 45, 90 triangle, what do? We multiplied everything by root 2. Well, this time, it's going to be a little bit simpler because this time I only have to do divide each side Okay, I'm going to divide each side by 2. So now look what happens here when I draw my triangle and do that. So our hypotenuse, which was originally 2, we need to make it 1. Remember, we're trying to get it to fit in the unit circle. So 2 divided by 2, there you go. So you've got now a hypotenuse of 1. Okay, opposite of 30 degrees was 1, but when we divide that by 2, now it's going to just be equal to a 1/2. Okay, again, we don't have to rationalize or do anything here because 2 is fine, and it's just a constant. 1 over 2 is just 1/2. Okay, when we look at opposite 60 degrees, what was that originally equal to? Root 3, but when you divide that by 2, now you've got root 3 over 2. Over 2. Okay? And what I'm going to do, guys, is we've got our unit circle one, but I'm also going to go ahead over here, and I'm going to label this triangle A, because there are cases where if we don't actually remember our unit circle triangles and we just recall our special right triangles, we can go ahead and still find all this information as well. Okay? All right, so what is 30 degrees in radians? 30 degrees in radians is pi over 6. Okay? So what we're going to do here is we're going to draw a radius of 1 with a reference angle. Okay, we're going to draw a triangle here with a reference angle of 30 degrees. Okay, so 30 degrees here, that's our reference angle. All right, and so we have a radius of 1. Let's go ahead and draw a perpendicular line to the x-axis, and let's get our x and y. So based on what I'm doing is now is I'm fitting my new 30, 60, 90 unit circle triangle. I'm rewriting it again over here. So what was x equal to? X was equal to root 3 over 2. What was y equal to? Y was equal to 1/2. So remember, all ordered pairs are in the form of x comma y. So the ordered pair for 30 degrees is root 3 over 2 comma 1/2. So we're going to write that as root 3 over 2 comma 1/2. So again, by knowing my rules and knowing the ordered pair for 30 degrees, I can go ahead and I can find all these. Okay, I can go ahead and find all these. So sine of 30 degrees. Again, recall, x, y, x, y. So the rule for sine is equal to y. Well, what is y equal to in this ordered pair? 1/2. 1/2. So if I plug in sine of 30 degrees into my calculator, it's going to give me 1/2. See, what I'm teaching is you understand the whole why behind all this. Of course, we could use the calculator and just plug it in, but we need to understand where it comes from. Okay, we need to understand where all this comes from. So now cosine of 30 degrees. Well, what's my rule for cosine? On the front part of this sheet, we said it was equal to x. Well, in this ordered pair here at 30 degrees, what is x equal to? Root 3 over 2. Okay? So now, when we look at cosecant and secant, okay, cosecant, secant, what's going to happen here? We're going to go ahead and we're going to flip for cosecant. Well, that's nice when it's just 1/2. So when you flip 1/2, you just end up getting 2. Just end up getting 2. When cosine, same thing. We're flipping. Now this one is a little bit more difficult. 2 over root 3, you have to rationalize. Again, I'm going to skip that part for you. We should know how to do that by now. It's 2 times root 3 over 3. So the answer starts getting a little crazy there. All right? For tangent, I'm going to scroll up a little bit here. Still keep triangle A. It's going to be a lot easier to do triangle A. Okay? So you still can use the unit circle triangle, and that's fine because you're going to have access to your calculator. But it's a lot easier okay, and triangle A was just our original 30, 60, 90 triangle. It's nothing, it didn't come out of the middle of nowhere. It's just our original 30, 60, 90 triangle. Okay? And so, recall, what is tangent equal to? Okay, so tangent of 30 degrees, well, tangent, what's its rule? It's equal to opposite over adjacent. So if you use our original triangle here from 30 degrees, opposite 1 over adjacent root 3. Okay, and the reason why I say that is it's a lot easier than trying to do y over x based on the unit circle, because y would be 1/2 over divided by root 3 over 2. That's pretty crazy to do. Okay, with a calculator, not so bad, but still. And so what we find out then is that when we go back here and we're using our 30, 60, 90 triangle, we can find tangent to be 1 over root 3, which then ends up being just root 3 over root 3. So you get root 3 over 3. Which now recall, we have to flip. And so when we flip, we get 3 over root 3, which when you rationalize the denominator there, you end up just with root 3. Okay? So again, by knowing the ordered pairs here, by knowing the ordered pairs, reference angle of 30 degrees, right? And knowing my rules, which you went over on the front, I can now label out what sine of 30 degrees is, what cosecant of 30 degrees is, okay, what cotangent of 30 degrees is, without the access of a calculator. All right? Now, last but not least, we're going to look at a reference angle of 60 degrees. Okay? So all we're doing is the same thing here. Okay? First off, what is 60 degrees as radians? That would be pi over 3. So now we're going to draw a radius still of 1 here. Okay, we're drawing a radius of 1. Okay, but now this time, my reference angle is going to be 60 degrees. Okay, this time it's going to be 60 degrees. And sorry, that's not the, well, that's actually not too bad. So therefore, then up here, this is going to be 30 degrees. So we're still dealing with our 30, 60, 90 triangle. Okay, except now I just made the reference angle 60 down here. So I just swapped the angle places. Okay, 60 plus 90 plus 30 still gives you your 180. All right. So the thing you need to remember is that opposite 60 degrees in our unit circle triangles for 30, 60, 90, opposite 60 degrees was root 3 over 2, which that's our y value. And opposite of 30 degrees is 1/2, which is my x value. So then what is my ordered pair here? All ordered pairs in the form of x comma y. So then we're going to have 1/2 comma root 3 over 2. Okay? So x comma y, 1/2 comma root 3 over 2. Again, how did I get that? I'm using my special right triangle, my 30, 60, 90 triangle that we fit into our unit circle by changing its radius to 1. Okay? So in our ordered pairs for coordinates for 60 degrees is 1/2 root 3 over 2. So now that I have the ordered pair, okay, and I have my rules for sine, cosine, cosecant, secant, tangent, cotangent, I can go ahead and tell you what these are. So sine is 60 degrees. What is sine equal to? Sine is equal to the y value. So we have x, y. Sine is equal to y, so in this case, that's root 3 over 2. Okay? Cosine. Cosine is equal to x. Remember, these rules are coming back from the front page. I know I said that 100 times. I sound like a broken record. Again, if you're not sure where I'm getting these from, look at your rules on the front of the page from the first section there. We define them. So 60 degrees, cosine is equal to x. So what is x here at this ordered pair? 1/2. Okay, again, for sine, all we're going to do is we're going to flip. So when I flip there, I'm going to get 2 over root 3, which ends up equaling 2 root 3 over 3. Okay. Same thing with secant. I'm flipping cosine. So when you flip 1/2, that's very easy. You're just going to be left with 2. Now, asterisk again. Okay. When I'm finding tangent, it's a lot easier to use triangle A. I'm going to use my original 30, 60, 90 triangle, not this one here that's fit in, because it's a lot easier to simplify just by hand. Again, if you want to keep using this one and using your rules, go ahead and do that. Go ahead and do that. I'm not trying to confuse people. I'm just trying to make it easier. So tangent is 60 degrees. Again, what is tangent equal to in SOHCAHTOA? Opposite over adjacent. So when you look at triangle A back up top there, okay, back up top there, now looking at it from a 60 degrees. So my opposite side then would be equal to root 3. My adjacent side would be equal to root 1. I mean, not root 1, it would just be 1, sorry. So then root 3 over 1, that's really easy to give you. It just gives you root 3. So tangent at 60 degrees is equal to root 3. Okay, tangent at 60 degrees is equal to root 3. So then to find cotangent, what are we doing there? We are just flipping. And so when we flip that, we're now going to get 1 over root 3. Remember, it originally was root 3 over 1. Whenever you flip it, you got to put something in the numerator, guys. Cannot put a 0 up there. Can I tell you how many students want to tell me that that was 0 before? And so when you rationalize, you find out that you get cotangent of 60 degrees to be root 3 over 3. Okay, that was a lot. Take a deep breath. Okay, great thing about having a video is that you can go through it and pause it in parts that you really need it. Okay, I would encourage you guys, if you get the opportunity, to watch this video along when I teach it so that you don't miss anything. Okay, but really that's it. I mean, that's an introduction. Again, we're going to spend a lot of time this week on the unit circle, so do not stress out if you are having issues with understanding this material. We're going to really practice as much as we can. Okay, and I'm going to break it down as much as I can to you. All right? So thanks, guys. I know long video today, okay, but just something we have to do, and that's going to happen from time to time in pre-calc. But I appreciate you guys listening to me again and working hard like you are. Signing off, and I will talk to you guys in class on Monday. Have a great weekend. Bye.